we had an initial struggle where we would want companies to move from the intuition-based forecasting, where people would guess randomly what they think they would sell, to having some kind of a method where people would use some systems, some quantitative techniques. And what we have added in the last few years is a new dimension. It's not just some technique, but it's this amazing data science tool, which make forecasting so much more accurate and so much more precise, so much more useful than what we have experienced in the past. So I remember, just to give you a brief thing, that even with quantitative techniques, we would tell businesses that if you are at around 70% accuracy, be happy. I mean, there will be so much environmental variations, these techniques, but the new techniques, what we're going to hear about today, go way, way beyond, and help us forecast and plan inventory so much better. So I have two very, very knowledgeable speakers. Dan Sindrich from AWS, Amazon. He is the product manager, and I guess he'll tell us more about himself on this. And I also have Charles with me. Charles is the principal solutions architect, Charles Lawlin, also at AWS. He's also an expert in machine learning. I will pass on the baton to them, have them introduce themselves, and then take us ahead for the next 30-35 minutes.
Great. Yeah. Thank you very much, Piyush. Appreciate the invitation. Yeah. So Dan Sinreich, product manager for Amazon Forecast. Have worked with algorithms for a while. I'll also have a lot of experience in finance, not just supply chain. And then and Charles Laughlin will be my co-presenter today. Charles has a lot of experience in supply chain. Charles, do you want to introduce yourself very quickly?
Yeah, sure. Hi, Dan. Thanks, Dan. Hi, everyone. Charles Laughlin. As mentioned, I'm a solution architect, principal AI specialist here at AWS, and yeah, happy to learn more about your group today and share what we've learned along the way.
Great. And so I've got a few slides here. We'll aim to go quickly through them. Then we've got a demo, and then we'll take Q&A. And then feel free to pause and ask questions, right? So let me see. Tell me if you can see my screen here. And I've got a couple of screens. So if I look away, I'm not being rude. I'm just looking at a couple of other screens. Let me know if you can see my sharing now.
Yes, we can.
Yeah. Okay, perfect.
Yes.
Okay, so look, so today what I'd like to do is kind of talk a little bit about why forecasting is important. I think most of you understand that, but it's always good to highlight. Then we'll go into the meat of it, which is what is machine learning based forecasting. We'll talk about some inputs and outputs, how you get started. Like I mentioned in our pre-discussion, it's not that hard to get started. We'll talk through that. We'll talk about what a predictor is and building that. So in our lingo, when we talk about a predictor, what we mean is an actual machine learning model tuned to your particular data set. So that's a predictor if you hear us talking about that. A short demo of the inputs and especially the outputs. And then if we have time, we have a nice customer story about a retailer, and we can talk about others as well. And look, I know we're talking about supply chain here, and that's the focus of the group, but it's really forecasting is applicable across multiple functions. And just I wanted to highlight that it goes beyond the inventory planning that you see within supply chain. But we have customers that are using us for things like workforce planning. A couple of customers actually are using us for things like nursing, like nurse staffing forecasts, which are every 15 minutes, right? Childcare staffing, which are also more frequent. Certainly the inventory planning on the left is a little bit less frequent, right? Daily, weekly, monthly, but you certainly have these more frequent ones. Capacity planning, basically how do you allocate scarce resources even at short, what we call time horizons. And then with financial planning and business functions, we have, again, a customer who helps their customers understand potential revenue and sales numbers coming from an e-commerce store that they provide info for. So all of this we see use cases around forecasting, not just in supply chain. We'll talk about and focus on supply chain today. What's interesting and I want to highlight is that there's the McKinsey study that showed that more and more companies are starting to use machine learnings and they're starting to invest in this ML-driven forecasting. And what the study shows that there was anywhere, depending on who they surveyed, there was anywhere from between a 10 to 20% improvement in accuracy. And that went along with a 5% reduction in inventory and a 3% increase in revenue. So if you're running a large dollar volume, right, say $100 million business in sales, each percentage point is very valuable, right? And Piyush, you talked about 70% accuracy. I'll show you an example where we go much, at a much higher level of accuracy. So accuracy is important, and it's kind of fundamental to the operations and the successful operations of the business and the commercial success of the business in our view. So wanted to highlight that. Amazon's own forecasting journey is here, and so really there were maybe three phases you can break this into. So first, we began with traditional statistical models, which work very well for basic data sets and capturing simple trends. So here you got a picture with 3 items, basic items, not that many of them. But as things became more complex in the mid-2000s, we began investing in machine learning technologies to operationalize forecasting at a much larger scale. So that approach allowed us to manage scenarios where you have much different patterns, demand patterns, and where they vary by region, by product. And then around 2015, as supply chains and the number of products grew, we went from not just footballs, but just footballs with the Seahawks logo, or the Redskins or Buccaneers in your region. We started investing in deep learning to tackle some of these really hard problems around new product introduction, which you asked about. And so what's good about these deep learning models is that they're what we call global in nature, which means that they look at relationships across products, and they can learn from those relationships around those subtle relationships. And so this was the journey, and what we have today is really an outgrowth of that. Within AWS, we've made a number of changes, and what we use today is different than what Amazon uses, but and what we have today is different. So the service has really grown, but that's really the history of it, and that's sort of the outgrowth of it. And so this is what we try to do with forecasting, right? It does look at historical data, and we'll talk a little bit about this in future slides. But really, the goal is to make sure that the forecasted demand, which is here in the blue line, really is not under forecasted. In which case, you're missing opportunities. You can have a shortfall in raw materials, for example, in supply chain. So therefore, you don't have inventory to sell if you don't have enough. And then if you're over forecasting, there's wastage in products that you have to throw away, and in staff, and it's a lot of wasted investment. So we see a lot of complex spreadsheets and other financial planning software, but in the end, accuracy is the goal, right? And it's important. It drives those commercial results. So now we'll get into a little bit of sort of the meat of it, as I mentioned in the agenda. So let's talk about machine learning forecasting and how we think about it. There's really 3 separate steps. The first one is to look backwards, but also forwards, and I'll explain that. Then we identify the trends, and then using those trends we've identified, you project forward, right? So certainly, as I mentioned before, the machine learning algorithms absolutely learn from past behavior, and they're very good at taking that historical data and understanding relationships between products, and things like forward-looking data, like promotions, events, weather, really anything that you want to code in as the future certain algorithms can learn from that. And then we look over that historical data and identify trends within that data, right? And we'll talk about metadata and related time series that can help shape that forecast to the future. And then you project forward and you say, well, okay, well, I've identified these trends based on this historical data. Give me each line item, and we'll use different words depending on the industry. It could be SKUs, it could be products. We'll tend to generically in machine learning, we talk about time series machine learning. So each SKU or each product, we'll say each is a time series. So for each time series, let's predict the future value. What actually happens under the hood, I think it's important to just, it's a little bit like lifting the car hood, but then putting it down, because I used to be able to change my oil many, many years ago, no longer, but this is a little bit of peeking under the hood. There's a lot that happens beneath a machine learning process, right? And I do think it's important just for the purposes of this call to understand it, even though we don't have to do it, right? So there's certainly the preparation of the data, which actually some of this we do need to do, as I mentioned. Data science is a separate function than machine learning science. And so the preparation of the data here on the left has a lot to do with data science. So cleaning the data, making sure that there's no missing values, or if there are missing values, making sure that they're appropriately coded, adding in various data sets, whether they're feature specific things that you want to add about the item, or their weather, holidays, things like that we want to provide. Then we want to have our historical data, right? We want to take that actual historical data and break it into what we call training data, where we train the models to understand those patterns, and then the test data, which is how we will gauge the accuracy, because in the end, that's what matters, at least in this process, is the accuracy of the model. The building, training, and tuning is really very much in the machine learning function, right? As opposed to data science, if you want to keep those separate. Where you're looking at different parameters for the models, like different like learning ratios, how quickly they learn based on new data. You can then train these models. And one of the things we do, you'll see, is that in order to create a good forecast, we'll actually ensemble model, meaning that we'll put different models together to provide the best forecast for each time series or each item. We then calculate global accuracy metrics, explainability, basically, and export the data. So this is all what happens in the middle. And then there's deployment, which we touched on as well in the intro a little bit. Where do you host that model? So where does it sit? How do you use it? How do you compute inferences, which is basically the forecasts? And then at the end, how do you verify that model, once you've built it? Let's say I built it 2 months ago, or I built it a month ago, or I built it yesterday. How do I make sure that the data that is still that's coming in is still appropriate for that model, and our ground truth data, which is actual data that comes in? How do we know that predictor that we've built with data from 2 months ago, 2 weeks ago, how do we know it's still providing high quality metrics, high quality accuracy? And that's what we do with what we call predictor monitoring. To get to sort of to demystify this a little bit, I've got a couple of examples, and hopefully these will be helpful around what data is provided to machine learning algorithms. At least the way we work and the way we've architected the approach is that there's 3 pieces of data. There's historical data, there's related data, and then there's item metadata. And I've got examples on the next slide, but historical data is anything like, say, basically what you're trying to predict. So what is the demand, or what is the call volume for the call centers I mentioned before? What's the inventory that I'm trying to forecast? So what is the thing I'm trying to forecast? Related data are prices, promotions, in stocks, basically anything that you as a business person who has deep domain knowledge feels that can impact the inventory or can impact the forecast. And this is where our customers, again, domain knowledge comes into play, because they'll say, okay, I'm trying to forecast this, but I have a pretty good sense that this other thing impacts demand. So can I provide that to you? Sure, we'll take a time series history of that related data as well, right? And that can help build those patterns. And then it goes to the question of the cold start that we talked a little bit about at the intro, item metadata. So item metadata is anything that helps build relationships between products, and again, can help the algorithms better compute the forecast. That gets fed into our Amazon forecast service, and we provide forecasts and provide explainability. This is a little bit more detail. Again, I wanted to demystify it, right? And say, look, it's not that hard to actually use these things. As I mentioned to Piyush, it's a little bit more about the organizational, desire to do these things. But in terms of the pure data, pure technology, it's not that hard to get going. All you need, for example, to get started is the target time series. Most of our customers start with something very simple. It can be as little as 3 columns: the timestamp, the item ID. So what's the date? What is the thing I'm trying to forecast, and what was it? What's the target value? We allow things like locations, fulfillment centers, other dimensions that you may want to use to aggregate or deaggregate, slice and dice the forecast. But really, you can even think of the 3rd column as optional, and really all you need are the 1st, 2nd, and 4th columns. And here are some examples of things like item metadata, related time series. Related time series, this is an example of this is I would say frequently used by our clients. They start with this usually on the left, but related time series are popular. And it's things like prices, promotions, at what location for what item, basically anything that can drive that forecast. So here again, just outside of supply chain, I wanted to put some examples of what other customers are doing. Certainly within supply chain, things like economic indicators. So Bloomberg data has come in a few times that we've seen. Item metadata departments, things like that. But we have a large retailer who uses some of the metadata you see on the right: store sizes, shelf lives, anything like that can help build relationships. I will say, and I think it's important to know, and I have it here as a bullet point, most of that forecasting power, and most of it comes from historical demand data. The additional related data that customers put in can and often does improve the forecast, but doesn't always. And so we have something called explainability to basically show you that, hey, say which related time series that I've put in, whether they're promotions or things like that, which ones have either increased or decreased the forecast value. And it's one of the exercises we go with customers to say, hey, you've provided this related time series that could improve your forecast. But look, it doesn't do anything, or this one does have an impact. So, let's not focus on this one because this one has low ability to drive forecasts. But this other one is important, so let's focus in on that one. So there are these tools available to you to not have to be a machine learning expert to use forecasting. So I thought that's interesting. The other thing I do think it's important here. Sorry, let me go back. We do what I mentioned. Do ensemble modeling. So within our machine learning service, within Amazon Forecast, there's actually a combination of both statistical, more traditional algorithms. It sounds like some of you are familiar with some of these, Profit, MPS, and so on. And then we have the deep neural networks, which is the ones I mentioned that Amazon started working with in the 2015 era and later, once things got very complex. What's interesting about these algorithms is that each will have its different strength. And the point isn't necessarily to go in here and talk about all of them, but I just want to highlight that, like, for example, NPTS does well with intermittent spikes, right? ETS does well with small number time series. CNNQR does well with a lot of time series, right? And each of them has their strengths, and your products and the things you're trying to forecast will also have different demand characteristics. And we've noticed that. So what we do is that we will actually combine these algorithms in what we call ensemble modeling. So for each time series or SKU or line item, we'll actually figure out which combination gives you the best forecast. And it could be that the best forecast, and I'll explain what best means because there's also definitions of that. It could be that for one line item, 50% profit and 50% deep AR might give you the best forecast over time. For another item that has a very different demand pattern, it could be that CNNQR is 80% and maybe NPTS is the other one, right? So that ensemble modeling really helps to increase accuracy, because not any one algorithm is going to be perfect for every, or is going to be the best for every one, for every item. And then just sort of to finish up here before I go into a demo, a couple more points to highlight. The quality, I often mention the quality of the predictor. So how do you know that a predictor is quality? What we do here is we'll take the data that's given. So within machine learning, you give us a history of data, and we'll actually break that data into two pieces, roughly on these ratios. We use most of the data to train the predictor. Again, the predictor being a model trained on your data, and then we'll leave some of the data there for testing, right? So we want to see that, hey, based on what we've predicted, how did it compare to what actually happened, which is the ground truth test data. And there's these different measures that's the best for them, right? So for example, a certain customer, it might be, just to use an example, it might be that they want to look at the accuracy at a very specific quantile. So maybe they want to forecast at the 70th quantile to make sure that 70% of the time they meet the demand. And that's what they, for certain items, that's what they want there to be, the accuracy metric. Other customers, or maybe for other items, the same customer, maybe they're happy with just the overall deviation from forecasted value, because they've got so many SKUs that they're not, or so many time series that they're not necessarily going to go into each one. So it depends. The definition of quality depends, and you get to choose what, how you define it. And we have customers that will also define their own variant of one of these six. So that's kind of what I like a lot about machine learning, is that it gives you a very hard truth to understand if you're right or wrong, or if if what you're doing is accurate or not. And I like that empirical aspect of it. I'll just a couple more points here. Typically, this is what we call a flywheel to create a predictor. There is a trial and error aspect to it, and that should be accepted. And we see that a lot with our customers, where in order to create the predictor, they'll figure out what data they want to use. They'll propose that data. They'll create the predictor based on what they based on their views. And then they'll look at things. Hey, is this accurate enough? Am I happy with the accuracy metrics? Oh, okay, I am. Okay, or maybe I'm not. So let me look at maybe correcting some of that. So again, that goes back to the data science piece. Maybe some of the input data needs to be shaped in a different way. And then we run it again, and then we look at, say, well, do we want to look at the 50th quantile? Well, no. For some of these items, I'd rather look at the 90th quantile, because I want to be out of stock. And maybe some other items, I'm okay at the 25th quantile, the 0.25 one, right? So they'll go through these metrics, and they'll go through this approach to get something that they're comfortable with. The first model is typically, right? Is typically never the one that goes into production. So I think that's important to understand. And then I'll finish, before I go into the demo, I'll finish here in that everything we do is on a probability basis. And so especially in inventory management, these costs associated with under forecasting and over forecasting do matter. And so at different quantiles, you may want to predict items at different quantiles. So again, when we talk about a P50, it means that our forecast on average will be, on average, some forecasts will be above and some will be below. So 50% will be above the actual ground truth data, and 50% will be above. So that's what we call the median forecast. But for example, we have a retailer who chooses to forecast fresh food items at 75% at the P75, because they never want to be out of that. Because if you're out of fresh milk and fresh eggs, basically a customer walks into the store and walks out with nothing, right? And that's worse. And if they walk out with nothing, that's not good, right? So what they want to make sure that that they'll forecast items at a high probability level, even if it means that sometimes they'll be overstocked, because the impact of being understocked in that has a downstream impact on other things for revenues and their products. And that's really where you want to use forecasting as a way to drive the business. And this is what we see some customers doing. I'll pause there. And then what I've got, maybe what I can do is just give a quick demo now, and then with some of the results, and maybe take Q&A afterwards, if that's okay. Does that make sense? So, okay, so
Fine.
Okay, great. So let me move this here. So let me show you a little bit about. Let me see. Tell me if this. Yeah. Let's see. Let me move this up. Okay. Can you see my screen here? I moved. I'm using the browser here.
Yes.
Okay, perfect. So look. So this is essentially. So what I'll show you is both how the service looks, and I'll show you the console, right, of typically how you get started, which is actually how many customers get started with a console. In the end, they'll tend to automate this and use APIs and programmatically do this. But I think this is a nice visual to understand, and then I'll show you a couple of examples. So everything here really starts with what we call a data set group, and so we're within the AWS console here, and so within Forecast, I mean, this is the main page within Forecast, but everything really sits contained within a specific data set group, and here, for example, a specific data set group. So I've got several here. This, when you go to a data set group, it really shows you the nice flow of generating a predictor and using Forecast. So the first piece is here, where you import the data, and I'll show you how that looks. The second piece is you actually train the predictor based on this historical data that you've used. And also, if you remember, it's that slide where we said we peeked under the hood. It's everything happens. A lot of when you go to train a predictors are those items, are those bullet points we talked through that slide. It then generates the forecast that's also in that slide, and then you can explore insights around the forecast you generated, and we'll look at results. This is to import time series. So again, target time series. Oh, actually, let me go back. Remember, I talked about. Oh, sorry, it was some noise. Sorry. So remember, I talked about there being three pieces, right? Target data series. So historical data is here. Item metadata and related time series. These are the three fundamental types of data that's required. If we quickly just look at this, we won't go into importing it, but just to give you an idea, in this case, I just have three columns. As I mentioned, it can be as easy as taking just a timestamp. So when did something happen? What is it that I'm trying to forecast? I'm trying to forecast something for different items. So here's an item ID, and then here's a demand. Right, that's it. So timestamp, item, and then demand. This is what I'm trying to forecast. You can have it stored in CSV or Parquet. Within Forecast, we take it from S3, which is one of our flagship databases on AWS. So it sits here in an S3 bucket. The data does, and then you're basically importing the data, right? So won't do it now because it takes a few seconds, but you import the data. And then you can go and actually, once you have that data, you can actually go train the predictor. So again, a predictor is a specific model that's built on your data. And here you can choose, look, I want to forecast it, every week, once a week, and I want to start on Tuesdays. In fact, we have this is one of our one of our new features where we have customers that want to start on Sunday in the Middle East. That's when their week starts, so they can start on Sunday. How many? But let's say let's say you want to do a daily forecast. How many days ahead? You want to do 5 days ahead, or you want to do just 10 days ahead? You can put that in here. So 10 days ahead. You can choose your quantiles. Do I want to go to 15? Do I want to go to 20? Again, what p values do I want to forecast at? You can have a few more here if you want to. You can enable things like explainability, which again will tell you which of these items, which of the related time series made a difference and which did not in your forecast. Automated predictor monitoring, that's something that we have. And then and like this is what goes into a related time series. Certainly we have a holiday calendar that you can enable. So you can pick, okay, well, I want to use the US, US holiday calendar, weather index if you want to choose weather. And so anyway, so you have some options, but they're not overwhelming. But they are key options to select about your predictor, and you create it and off you go. And it creates the predictor. And then when you're done, then you can start looking at the forecasts. I think the best way to look at the forecasts is to look through this here. We put that into a visualization dashboard forecast. And let me explain what you're looking at and sort of to understand the significance of it. So here we've taken data. This is publicly available Walmart sales data on a Kaggle. It's called Kaggle, is a website where there's a lot of contests and competitions online about other things, many things, but including time series machine learning. So anyway, so we took this data and we predicted 12 weeks out. So we took the historical data that they had, and the goal was to predict 12 weeks out for 45 stores and 78 unique departments. And so Piyush, in the beginning, you mentioned that 70% accuracy, you were happy with 70% accuracy at some point, right? Here, we've got an accuracy of, it's 100 minus this, so 98.6 roughly. So our P error, so our error at the P50 is 1.39, which translates to 98.6% accuracy at the P50. Remember, that's the median. $554 million in sales, right? Our forecast was 546. Look, every P number, every percentage is 5.5 million. So there's actual money at stake here, and it makes a difference. And you can see the forecast is by store. So remember, we had 45 stores. So, store 1, department 1, department 10 out of 78. What were our sales values at each of the Ps? At the 50s for each store, for each department. And it gives you the percentage error here. The nice way, and Charles, and I have to give credit, Charles put this together, but the nice way to look at this is to look at it over time like this and to say, well, okay, how did we perform over time? So so this is about data from 10 years ago, hence it's publicly available, from September to, from the 7th here to the 28th. How did we perform? The black line is the actual ground truth data. So that's what we call the target value. This is what we actually imported. The blue line, which is here, this is our P50. So how did our P50 do on average? And then this is the P60. Again, if you want to make sure you're not out of stock, if you want to have a forecast that's at a higher p-value, you can do that. And this gives you a good idea of the bounds of the forecast. So you can see how it trends over time. Again, on average, it ends up at 1.39% error. And I'll finish with this. I think it's important not just to look at these broad metrics, but you can absolutely drill down, right? But the key is not to get lost in the drill downs of the metrics. This is a very nice heat map where you've got stores on the y-axis and you've got departments on the x-axis here. And it shows you essentially how accurate were you for each store department combination. Certain departments like 77 and I believe 50 or 51, one of these is large appliances, the other one is gas. So not all Walmart stores carry heavy appliances or major appliances, and not all of them have gas. So you'll see these yellows, these grays here. But then what's interesting, you can actually start making business decisions both at the store level and at the department level. So for example, you can look at department 38 and say, well, what is it about department 38 where we see some of these reddish lines, reddish squares, excuse me, and is there something where we have some tendency to either under or over forecast here? So you can go here and say, okay, what, is there something specific about department 38? And this is when you go back into what we talked about earlier with item metadata. In other words, can I add some item metadata to maybe indicate, for example, if these are seasonal items, can I add something about seasonality in my related time series to improve this? So that's like the immediate question you would ask, but you'd have to figure out what department 38 is. And then same thing on a store level, right? You can eyeball this and you can say, well, it's interesting that store 14 looks like I've got some, looks like I've got a few more reds. And so it looks like my forecasts are a little bit less accurate here. So why is that? And this is the example. It could be the first thing that came to mind looking at the dates and looking at who it is. Hey, could this be a store in a football town? So I went to school at Auburn, and I can tell you that a game day absolutely made a difference in traffic at our local Walmart, and I was there, right? And so, is there something about this store that maybe we could improve the forecast with by adding certain dates, like the Auburn football schedule, right? Which is roughly in the fall, but certainly tends to differ by week. So this is something that it's a simple, and maybe somewhat silly example, but this is the kind of info that you can get. And the way to figure this out, you'd go talk to the manager, go understand what's happening on the ground in store 14, and then look at what could potentially improve the forecast. And that's that flywheel that I mentioned earlier. So let me pause there. I think I went a little bit over, but hopefully you have a good idea of what we can produce and how it's used. So
we will jump to questions. Julie had a question she put up first. Do you want to ask that, Julie, or should I read it?
No, I can ask too. Yeah, I mean, I was just wondering because, that's kind of traditionally the type of historical data and other type of things that we put in the model. But, you mentioned about the weather and holidays. That's perfectly good. My question was about, well, first of all, in demand forecasting, we really forecast people, right? People's behavior and whether they're going to purchase something or not, especially we've seen that in the recent years, right, in the retail. So we're not really forecasting products. But of course, once you forecast the demand, then, you have to forecast your inventory and how it's going to be distributed and so on, then gets to that. So I was just wondering that if we can, in your current modeling, do you have anything about that particular company's customers, how their buying behaviors, so it can be incorporated that in the model, so that maybe it'll be more accurate forecast at the end?
Yeah, and maybe I'll let Charles comment on this one because he's seen much more. But if you had that kind of information, you would add that in potentially in related time series, but it's not. You'd have to manipulate the data, or you'd have to bring in data that represents those behaviors, right? Mm-hmm. Charles, do you want to add anything to that?
Yeah, and I think just to back up at the macro level, so AWS platform, the thing that we've looked at today, it doesn't. It is just a platform, a tool, a service that you, the customer, decide how you use it. And you do that in privacy of your own account. So the data that you provide is encrypted. You can encrypt this with your own keys. It's encrypted in transit and at rest. We don't have any insight about the data, what you're doing. We provide the service and bill it as a utility. But as a customer, you design your data, you design your schema, and then provide that. We do sell inside of AWS, we do provide, it's called data exchange. So this is a way to get kind of third-party data. These are people that publish data like economic data, health data, et cetera. There's a few thousand data sets that are out there. And then there's also, as you know, third-party data providers that sell data, the Nielsen's, the IRIs, and others. So you would bring any data that you think is useful in building, a better explainable model and bringing a higher accurate model. You bring this data, you shape it as you like, and you build these models in isolation. These are all just API calls to provide the outcome. But we AWS don't have any insight as to what you're doing, and we're not providing extra data. So with that disclaimer in mind, one of the things that customers do, I know Dan mentioned this on an item basis, but we do have plenty of customers that want to forecast at their customer level. So that customer could be an individual consumer to understand that consumer's likelihood, but it could also be a form of a business-to-business relationship as well. But that's something that you would just design in your schema. I know Dan mentioned that, and he's right, it's a 3-column minimum, but you can have up to 10 columns in that set that allow you to have a very fine bottom-up forecasting approach, or you can decide to take mid-level or a top-down approach. But I want to leave you with just one note that it's very flexible. You can control the destiny.
Thank you.
Good.
The 2 questions from Anurag and Lee, guys.
Yeah. Go ahead. Yeah.
So that tool is another one of, it's another service. It's called QuickSight. So it's essentially a serverless way to approach BI without having to have any commercial terms or buy things, large outlays of expense. It's just a pay-as-you-go service. But all we did in that case is when the forecast process completes, it leaves you with CSV files. So, imagine a CSV file that would be your item, your time period, and then those quantiles Dan mentioned, just a simple CSVs. So all we did is just take that data in its natural state, no manipulation, and we just put some views on top of it. So what you were seeing there is at the top level, the presentation tier was QuickSight. You can use another tool, any tool that you prefer. It could be Tableau or anything else, and just feed that data in. We did have a middle tier. It's called Amazon Athena, which is a serverless way to go and query data without having to provide. So think about, large scale data warehouse capability, but not having to buy a commercial license or run a database. It's a serverless way to go get the data. So that does sit between the CSVs on our S3, which is our storage platform. So that's kind of what you were seeing at the bottom, S3 storage. Athena as a way to query that storage using SQL, and then the QuickSight was the presentation tier.
Yeah, and everything is, just to answer exactly, and yes, everything's available outside of Amazon. It's pay as you go, and you can sign up with a credit card, and absolutely, it's all part of the service. Just go to awsamazon.com if you want to. So that's available. All 3 items, everything I showed, everything Charles mentioned. Is there a version for academic purposes? It's pay as you go. So at this point, not really, but there are free. We should mention for each service, there's a free tier. I don't want to make this too much about Amazon. I want to make it more about machine learning. But yes, there is a free tier out there, and typically that gives you the ability to trial things and run a few items without a lot of cost. So we can talk about that. But that is available. And yes, the results that I showed are for the ensemble model, where we take all 6 and we create the best results, what I was showing with the Walmart heat map data. That's right.
You guys can ask questions. You don't have to put it in the chat. Just feel free to ask. So Lee's question about, is it only for short term? Can you do long term also?
Yeah, absolutely. You can do long term. Yes, absolutely. You can do monthly predictions. Annual predictions if you have enough data. What's interesting, if you want to do annual, you can. It doesn't matter. The issue there is one of history, and typically this is a soft limit that we have, and other people may choose to have different limits, but we have a limit that we need at least 4 times the data to create a forecast. So if you're trying to do, say, let's call it daily for a month, right? So daily forecast for a month, you need at least, at the very least, daily forecast for 4 months going back in history, right? Obviously, more is better, no question about it. We'll take as much as you can get, but at least for when you start going to long-term forecasts, such as annual, well, look, I used to work in finance, and it's very, very hard, even in finance, to get long-term history. And then what you end up with the situation is that long-term history, if you're trying to provide 4 years of data or more, the question is how relevant is the data from, I'm making it up, 10 to 12 years ago to today's business environment and supply chain environment. And I can tell you from history and finance, it runs out of relevancy very soon. So you just have to, and that goes the same thing here. It's a different supply chain environment, selling different products than you were 5, 10 years ago. So you get into that issue, but the algorithms themselves, they don't care, right? But there's the practical point of it.
Thank you. Pete, you want to ask your question?
Sure thing. Can you folks hear me? Yes? First, I just want to say, Dan, Charles, thanks so much for your presentation and for certainly sharing your expertise today. I just had 2 quick questions for you both. One was wondering if you could share, again, high-level, customer anonymous, what is your biggest success story and what impact did that have on the client? If you could share that with us. And then second part of the question really is just, how do you folks manage to keep up with the rapidly evolving technology in the machine learning space? I mean, how do you keep on top of this? It seems to be, rapidly evolving year over year.
Yeah. So maybe look, I'll take one. So more retail. So we have I'll give you one of the success stories. We've got a few more, but basically we've got a large retailer in India that I think they're in the top 3 that basically increased forecast accuracy from 24 to 70%. I have a slide on this actually, and then reduced waste up to 30%. And so that improved their gross profits by about 25%. They've got about, they got over 1,000 SKUs and 600 different stores. And they're using machine learning. They're able to literally increase their gross profit by reducing waste and making sure that they have the items in stock that are going to drive other purchases. I would say that's one that I can point to, right? Charles, any others you want to talk or about how we keep up with it?
Yeah, I'll talk about that one. But I can say we have a high 5-digit number of customers who generate jobs each week with our service. And so when we talk about a customer, it's only because, like with this more retail, we go through a very rigorous process where we work with the customer to be able to share their information. Otherwise, what they do is we're completely blind to, but we. So think about, everything we do is in confidence, so to speak. So we have a lot of across the world, a lot of different industries. In fact, I'll just answer one of the longest ones I've seen is a 30-year horizon. It's a financial system, and they know that 30 years out is probably less predictable in that 30th year than year 1, but we can do that. And then in terms of just our science piece, so we've got several PhDs that work on a science team that iterate over the latest technologies. We are constantly working to improve the service behind the scenes. So for example, the ensembling that Dan mentioned is something we launched last fall in November. This year we have a couple things I can't talk about now, but we've got a couple things in in our algorithms that'll be released this year that improve outcomes, in certain situations where the data shape, would benefit. Cold starts would be one thing I can mention as one, just a better way to handle cold start. And here, when I say cold start, I'm talking about no sales at all. You've got a new product you want to make, a new sweater. You have no history for this product, but how will it fare? And we're also making other features this year, such as the ability, we've already had this ability to support what if scenarios. So if you want to change things in the future, like if things go on sale or not, or if you're more optimistic or pessimistic on the economy or these things like this, you can run these what if scenarios. But but we're constantly, we have a dedicated team who does nothing but this. And every, nearly every day we're producing a little small changes to the service. But as a customer that would use this, it's just an API call. Like the heavy lifting that goes on behind the scenes, either in the science or in the provisioning of hardware to handle the data at any scale, is all kind of made automatic.
Sure. Thank you both. Appreciate your time.
Sure.
Appreciate it.
And if you're interested, look, I can send later. We have other, it's not just more retail, like we have other winning stories and customer success stories. We've got different blogs that we highlight. So we've had some nice success, and customers have had nice success with these forecasts and improving their business, which is what we care about. So
All about, yeah. Well,
and
congrats.
that's what in the end it's what matters. So yeah.
Agreed. Thank you for answering my questions.
Sure.
Any other questions?
Yeah, I have one. I like that heat map. That's not a question, just an addition here. It would be nice if you can put a GIS point over there, location with not just the store number 2 or 3. I guess you have that, right?
The data that we got did not have it because it's public. Again, this is publicly available.
Right. Yeah.
But you absolutely, you could, when you bring in, and again, when you bring the data into QuickSight, you'd absolutely, I'm looking at it on my other screen, instead of having numbers like what I was showing, absolutely, you'd have names and departments, absolutely. And then you can go, you can make some really nice map-related charts and all that. Here I just focused on the forecasting accuracy and some of the intuition and some of the additional info you get from doing these forecasts to understand that, like, hey, there's some, strange is not the right word, but there's some interesting demand patterns in certain stores and departments that maybe require additional related time series. And frankly, to be honest, it's just on the ground investigation to understand what's happening. We're not going to replace that, here we're going to give you insight, but to fix it requires that domain knowledge. So.
Yeah, the foot soldier. Listen, my question, actually the last one, I'm so sorry, I know we're running out of time. So all of these P75, P50, you're assuming we know the distribution of the demand, right?
Based on, Charles, you want to take this one? It's based on the historical data, right? I mean, we do. So
yeah. Behind the scenes, we kind of featureize that and kind of balance it. Kind of doing some transformations on the data because it may be skewed or have some kurtosis to it. So we'll actually behind the scenes do some pre-processing, get it to kind of a normal distribution for that feature, and then so this is things that happen behind the scenes.
But if the product is having a growth on sales, is it that distribution will maintain or the center will shift? I don't know if you do that in the algorithm or if it's the analyst that will do that adjustment, or is the machine learning that will do it? That's what I'm interested.
The latter, the ML part, the machine will pick up on these changes. So mostly what we see is a typical cycle where customers have a cadence, and that could be daily, it could be intraday, but maybe daily or weekly or monthly, quarterly. But the customer has a cadence, and every time the cadence looks like this, they bring the latest ground truth data that's emerged, the latest sales up to the minute. They import the data and then build a forecast. Occasionally, as Dan mentioned, it might be required to build a new model, but the idea is that first is all these quantiles, but then secondly, this is actually where it turns into a business case, is these quantiles, each one of them have repercussions, choosing over or under, and a lot of, there's a reward function in there, right? There's the reward of having, and then the penalty of overstocking. So nice thing is that a lot of times the reward is a lot more than the risk. That's how business is successful. It's better than Vegas odds. So, but yeah, we can, if the customer asks to, we can provide some guidance on how to maybe automatically choose a quantile across what sometimes can be thousands or tens of thousands of things that are predicted. That item could be a customer, that item could be a SKU or otherwise, but whatever that thing is, it's really improbable that an analyst can go and know each one of these things and tune every one. So the idea is to have kind of some math to do some optimization post forecast, and then automatically pick right quantiles. And then you get into things like, control charting and standard deviations and such. So the idea is that as an analyst, you don't want to touch all of them. You want to touch only the exceptions and the outliers, and then let the systems get into kind of an automatic handling. Because a lot of times this, what I know, right, my tribal knowledge and my own intuition, a lot of times, machines do, the math does outperform on the long, law of averages. It does outperform. So it's getting that trust and in a way, like at Amazon, for example, there, billions of packages a year, 185 countries. We don't select how many products of every style go into every one of our fulfillment centers. This is more automatic, and we do have people that deal with the exceptions, but generally that would be the idea. Let the math, trust the math.
Yeah, thanks. Good point.
Yeah. One last question, a little bit over time, but anybody has a last question? I would like your view on this idea of how do you convince people to change their existing forecasting methodologies to adopt these new techniques? Because I've heard frequent things like, this doesn't work for our product, we are different, our industry is different, machines can't take role of humans. How do you change that?
Well, we're a little bit peculiar, our culture at Amazon. We strive to be the most customer obsessed company on earth. That's our mission, and it has been. So we follow that with AWS. And so we're really not here to sell. We're here about customer outcomes. We don't have quarters, we don't have quotas, we don't have quarters or years to worry about. So in our case, every customer we talk to that has an interest in this service, of course they're going to want to kick the tires. Of course they're going to know, how does this service perform against my own data? And it's customer decision here. So we're here as scientists to. I apologize, I need to pause something. We're here to inform customers of art of possible and guide and provide guidance, but ultimately it's customer decision. If that means it's something else, then that's what is the best choice for them.
Yeah. And look, we'll also work on a small scale. Look, we'll start with a POC, right? So we'll say, hey, look, don't change everything about what you've done, but let's start with a small number of items, right? Let's do a test case. Let's start small, and you'll see, are you comfortable with these results? Is it improvement, right? And you sort of really start small, and you go up, and as customers become more comfortable with what they're seeing, that they'll tend to expand usage. It's the typical thing. And look, Piyush, to answer the last question is like, it never hurts to have executive sponsorship, right? So, obviously we've had cases where there's a top-down mandate to do this better, and then customers are much more open, right? Even though it is true, there may be resistance at the data science, machine learning level if they've got those folks in the organization. Oh, well, I can do this better. We built our own models. Like, there is that. It's just like Charles says, look, we were focused on your outcome. Let's start small, and look, you can spend your time on other things, the things around this. That's sort of some of the tools we use to get people comfortable. But
right. Thank
I'll
you.
leave it there.
Dan.
Yeah.
Thank you, Dan. Thank you, Charles. Appreciate your time very much. And thank you for everybody in the audience for supporting this venture and coming every second Wednesday to keep learning. That's what our objective is. So yeah, we end this session here, and I'm sure Dan and Charles will be happy to get more questions from you. Please stay tuned for announcements of regular sessions. Remember, it's second Wednesday of every month, the same time around lunch, 1 to 1:45 too, that we have these sessions every month. Looking forward to having your continuous support. And if you have anything to discuss additionally on forecasting or supply chain, we'd be happy to talk to you, listen to your stories, and maybe even present to students and see how we can improve the overall supply chain scenario. Thank you, everybody, and looking forward to see you next Wednesday in August. Thank you.
Thank you all.
Dan, Charles, thank you, gentlemen, for sharing your time with us on behalf of the Center for Supply Chain Excellence. And I know your time is valuable. Thank you for your time today.
Yeah,
It's all our pleasure. Thank you so much.
Thank you.
Thanks for the opportunity. Thank you.
Thank you.